Hello guys, today I will try to solve the binary tree vertical order traversal problem. Let's see the problem statement. Given a binary tree, return the vertical order traversal of its nodes value from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. Okay. How to solve this problem? Let's see the example. In this case, you should return the 9 and then 3, 15, and then 27. How to get this answer? Say you are at root and you can see this root node as the 0, 0 in the you can see the 3 as the 0, 0, and its left child should be -1 because it's on the left of it. So the horizontal distance should be -1, and this 20 should be +1. And okay, we go down and we are at 20 now. The same idea. Now the 15 is +1 -1. So it's the same, it's 0 now. So it's in the same vertical line with the 3. And how about the 7? Because the 20 is +1, so the 7 is +2 because we plus 1 on the 20. So this is the idea. We have to calculate horizontal distance of each node and then put them together, the same horizontal distance in the same group. That will be the answer. So as I said, we need to get the horizontal distance of each node. So a simple way is that I made another class that will have a tree node, and it will also have a horizontal distance. And the constructor node, tree node root, and int horizontal distance. This star root will equal to root. This star horizontal distance will be horizontal distance. Okay. So I will use hash map. Why? Because if I get the horizontal distance, I can simply put it into the list, the same horizontal distance list. So that will make this in constant time. So I will use hash map. Okay. But I still need first need this result list, new array list. Okay. Edge case, if root equal to none, simply return this list. And then we will do BFS. Why? Because when we do BFS, we can get the horizontal distance of the current root and its left or right root. That can make this easier. So I will use node q new linked list. Okay. I will first offer this root node into it. Its horizontal distance will be 0. Okay. And we do the typical BFS while q is not empty. Okay. Node cur equal to q pull. Okay. Do not forget we need a int minimum horizontal distance. First, we initialize two integer max value, and the max horizontal distance will be integer minimum value. Why? Because the hash map do not have order, and in the last we should return the list in order. So in this case, we just need to save the minimum horizontal distance and maximum horizontal distance. Okay. So we get the current node. Map. I haven't initial map. Integer. The key is the horizontal distance, and the value is the root value. Okay, map new hash map. Okay, map put if absent. If this horizontal distance not exists, we need a new array list. And then I will add that, get this cur horizontal distance and add what? Cur root dot val. Okay, add them into it. And if cur root dot val, cur root dot left not equal to none, we will offer them into the new node cur root left. This is the root, and the horizontal distance will be cur horizontal distance -1 left, so it's -1. If cur root dot right not equal to none, q offer new node cur root dot right and the cur horizontal distance +1. Okay. So in this case, we have traverse every node, and in the end, we should get our answer. We should do that. Oh, do not forget to update the minimum horizontal distance will be max minimum horizontal distance, and the current horizontal distance. The same max horizontal distance will be max horizontal distance and current horizontal distance. Okay. In the end, for int I equal to minimum horizontal distance I less or equal than max horizontal distance I plus, I will add them into the final result get I. So finally return risk. Okay. I think it's right. Okay. Okay, thank you for watching.